Hi guys, please follow along in your day 3 note packet as we graph tangent and cotangent. So hopefully we remember that tangent of x is the same thing as the sine of x over the cosine of x. And just as a reminder, the way that we would graph sine here is we would label our x-axis out to 2 pi, cut it in half at pi, half again, pi over 2, and 3 pi over 2. Go up and down to 1 and -1, and we're ready to graph. The sine curve starts at 0, 0, up at 1, 0, -1, and 0. And the sine curve looks like this. A reminder about the cosine graph, pretty similar. Set up your x-axis. If you need to pause the video to fill this out, that's fine. Oops. This was a +1, -1. And remember, our cosine graph starts up at 1. So 1, 0, -1, 0, +1. So that was just a refresher of what our sine and our cosine graph looks like, because today we're going to be graphing the tangent. And tangent is sine over cosine. So if I'm trying to graph tangent, I am first going to graph the denominator, which is cosine, to see where my asymptotes are. So I'm going to make myself a note that I am first going to graph y equals the cosine of x. And we know how to graph that. We're going to go out to 2 pi, cut it in half, half again. I'm going to make it go up to 1 and -1. And I'm going to draw this in pretty light because this is not my actual graph. So cosine starts at 1, 0, -1, 0, +1. And then this is my cosine graph. Dot it in or just draw it real light. And now we're ready for the actual tangent graph. So the tangent graph is going to have asymptotes wherever this cosine graph is 0. So here and here. So let's draw the asymptotes in. And then what a tangent graph looks like is in between the two asymptotes. So exactly in between, which is right here, there's going to be a point on the x-axis. And a tangent graph squiggles up left to right. It looks like this. More specifically, there would be points halfway between the middle and the asymptote. It would be up at 1. Right here it would be up at 1. I'm not going to be real particular about us having those plotted, and same thing down here at -1. As long as you have your middle point in the shape of your curve, that's what I'm looking for. And so the same thing over here. I've got, this time I don't have another asymptote. If I did, it would be over here, and my graph would look like this. But because I don't have another asymptote, it's just going to be this point. Tangent graph always goes up as you move left to right. So if I come here after this asymptote, it's going to go up as I move left to right. So it's going to look like this. To figure out the period for tangent and cotangent, it is different than all the rest. So the period for tangent and cotangent is pi over b. So that's different. Please make a note of that. And what the period is how long it takes to do one full rotation. And if we look, this is one full rotation. Or I could say that is one full rotation. Okay. Now let's try one below that has the number 2 in the front of it. Okay. So as soon as you see a tangent equation, you are going to first graph cosine, because tangent is sine over cosine. So first I'm going to graph 2 cosine x. And here you need to be careful because the period for cosine is 2 pi over b. And since I'm graphing cosine, I need to graph using that period. So 2 pi over 1 or just 2 pi. So let's set up our cosine here. So period's 2 pi, so 2 pi, cut it in half, half again, amplitude for that cosine is 2. And then I'm going to lightly graph the cosine. 0, or start up at 2, 0, -2, 0, +2. So my cosine graph looks like this. But remember, really we're trying to graph the tangent graph. So really I'm going to put my asymptotes in wherever this cosine was 0, so at pi over 2 and at 3 pi over 2. And then you have to remember what the shape of the tangent looks like in between the two asymptotes. So right here, we're going to have a point on the x-axis, and it is going to squiggle up as we move left to right. So point here at the origin, squiggle up as we move left to right. Squiggle up as we move left to right. The only thing that this 2 is doing to it is, if we were going to be real exact, right here, halfway between pi and 3 pi over 2. So right here, we would be up at a height of 2. Okay? So after we have it all nice and graphed, let's figure out what's going to go in these blanks over here. So the period for tangent is just 1 pi over b. So b is 1, so it's just pi. There's no vertical shift. There's no phase shift. Your domain. Remember, our domain, whenever we have asymptotes, needs to look like this. X such that x does not equal. And then we list our first asymptote. So pi over 2, plus or minus. And the question is, how often is this period happening? I'm sorry, how often is this asymptote occurring? And the asymptote is always occurring whatever the period is, okay? So my asymptote, this distance is a distance of pi, k. Or you could think of it like this. This could be any asymptote, and this is the period. All right, range. We're just going to look at our graph to find our range. Our range is our lowest to our highest point, and these graphs are going from -infinity up to +infinity. So there is our first one. Let's take a look at example number 2. So example number 2 says 3 tangent of 2x. So 3 tangent of 2x, I'm first going to graph y equals 3 cosine of 2x. And I'm going to say that the period for cosine I know is 2 pi over b. So the period of this is going to be 2 pi over 2, or just pi, which creates us a little bit more work. If the period is pi, I have to go out to 2 pi, and then I have to cut 2 pi into b sections. So I have to cut it into 2 sections. So cut it in half, pi. And then I split each period, so from here to here, into 4. So pi over 2, pi over 4, 3 pi over 4. Cut it in half, half again. My amplitude is 3 for the cosine graph. Tangents, I will never ask for amplitude, because amplitude is how high and how low you go, and a tangent graph goes all the way up to the top. Okay, so let's graph. This is a cosine graph. Go ahead and start up at 3 and put all your dots in here. Once your cosine graph is in, then you're ready for your asymptotes. My asymptotes are going to be at pi over 4, pi over 3, or I'm sorry, 3 pi over 4. And I've got 4 of them. In between the asymptotes, make sure your tangent graph has a point on the axis and squiggles up. Just make sure it squiggles up and always has a point on the x-axis. Then we're going to list out the information for tangent. The period is pi over b. And so the period for this tangent graph is pi over 2. There's no vertical shift, there's no phase shift. Our domain is x such that x does not equal your first asymptote. It really can be any asymptote, plus or minus the period k. So that is asymptote, and that is the period. And your range is how high and how low you go, and we are going from negative infinity to positive infinity. Okay, number 3 has a vertical shift to it. So first we are going to graph y equals negative 2 cosine x. Now we're also going to keep in mind PAV, phase shift, asymptotes, then vertical shift. So vertical shift doesn't come until the very end. So if I set this up, I'm going out, period of cosine, which is 2 pi. So we're going out to 2 pi, go ahead and label. If I'm graphing cosine, be careful, the leading coefficient of this cosine is negative 2. So that means I've got to start down at negative 2 when I graph this. Negative 2, 0, positive 2, 0, negative 2. Graph your cosine in. There is no phase shift, so I don't need to worry about that. So that means I'm ready for my asymptotes. Asymptote, I've just got 2 of them. Okay. Took care of our asymptotes. Now we're ready for the vertical shift. So think about what normally this tangent would look like. Normally it would be a point here. But instead of being a point here, I'm going to shift it up 1. So my key point is now going to be up here. Something else to consider that we haven't seen before is a negative in the front. Whenever a tangent has a negative in the front, it squiggles down left to right instead of up. So again, instead of having my point at the origin, I'm going to move it up 2. So my point is now here. And my graph is going to squiggle down. Left to right, the graph squiggles down. Okay, my period is going to be pi over b, or pi. Vertical shift up 1. Domain, x such that x does not equal your first asymptote, plus or minus the period k. Range is always going to be the same. Okay. Let's look at one where the period is different now. Number 4. Okay. Number 4, feel free to pause if you need to, if I'm moving too fast. We are first going to graph y equals 3 cosine of 1/2 x. Now the period for cosine we know is 2 pi over b. So the period for this cosine is 2 pi over 1/2, or 4 pi, which makes me happy because it's bigger than 2 pi, greater than or equal to 2 pi. Which means we go out to 4 pi. And remember, that's the period. So you're going to just take that and break that into fourths. In half, half again. And this cosine had a 3 in the front, so I'm going to make my cosine graph go up and down to 3. It was a positive 3, so that means I'm going to start up at 3, 0, negative 3, 0, and positive 3. We're going to draw that in pretty lightly. And then there are no shifts on this graph, so we're ready for our asymptotes. Pi and 3 pi. There are no vertical shifts, so I'm just going to have a point right here on the origin. And then I look back, this was a positive 3, so that means that this tangent graph is going to go up as we move left to right. Up. Up. Okay, so as you trace left to right, your graph must be going up. Now let's fill in these right here. So the period for tangent is pi over b. Well, pi over 1/2 is 2 pi. No vertical, no phase shift. See if you can find your domain on your own. Okay, check yours with what I have up here and see how you did. Okay. We have a lot of examples, and so out of these two graphs, I'm looking at number 5 and 6. I'm going to actually skip over 5. That's my easier of my two, and I'm going to do number 6. So number 6 has everything going on with it. It's got a phase shift, a vertical shift. So the first thing I want to do is factor. Y equals 2 tangent. Take out a 2, x plus pi over 2 minus 1. So I just took out that 2. Then, just like before, I'm going to first graph my cosine because tangent is sine over cosine. So y equals 2 cosine. And when I have a phase shift, I graph it with the cosine. Oops. There we go. 2 cosine 2 x plus pi over 2. So if I'm graphing this cosine graph, the period for this cosine graph is 2 pi over b, which is 2 pi over 2, or pi. So let's set that up. So if the period's pi, I'm going to go out to 2 pi, and I'm going to cut it into b sections, to 2 sections. Then I'm going to cut each period into fourths. Then super light, well, actually, let me set up my y-axis. Then super light, I am going to graph this cosine graph. Okay, I'm not going to do the phase shift. I'm just going to graph the cosine graph. I'm going to start up at 2, 0, negative 2, 0, 2. You'll notice you'll have 2 full rotations here. Okay. And then I have to think, whenever I have shifts, P, A, V. P means phase shift. So if there's a phase shift, I need to do it first before finding my asymptotes. And there is a phase shift. It is going to go to the left, pi over 2. Notice, pi over 2 is 2 units. So I need to go to the left 2 dots. So I'm going to take this old point over here on the right and scoot it to the left 2. So now it's over here. Oops. Now it's over here. This guy's moving to the left 2. Every point needs to go to the left 2. Don't move any vertical shifts yet. And fill in the rest of the pattern. So now I've done my phase shift. Now it's time for asymptotes. So now I'm going to put asymptotes. And notice they actually were in the same exact spot because before shifting them. Because when I shifted, I stayed on the same spot on the x-axis. That doesn't always happen. So I put my asymptotes in. Now I'm ready for the vertical shift. So normally a tangent graph has a point right here on the axis, and normally it would squiggle up. But we're going to take that point and we are going to shift it down 1. So now it's going to go down 1 right here, and it's going to squiggle down. Down 1, squiggle down. Oh, I'm sorry. It's a positive tangent graph. I hope you caught that. So it's going to be down here, but we're actually squiggling up. I hope you caught that when I did that. We're squiggling up. Tangent graphs go up as we go left to right, unless they're negative. Okay, so kind of messy, but that's what my tangent graph looks like. Let's label in our period and all this stuff. So the period is pi over b. So in this case, it is pi over 2. My vertical shift is down 1. My phase shift is to the left, pi over 2. Try your domain. And my range is negative infinity to infinity. Okay, that was tangent. We still have cotangent. Good news is there's only 2 problems that we're going to graph on cotangent. So keep going in your notes. And cotangent is cosine x over sine x. So the cotangent, we're going to be graphing sine first. It has an asymptote where the sine x equals 0. The period, just like tan, is just pi over b. Okay, let's graph it. So I am first going to graph the denominator, which is sine x. So let's graph sine x somewhat quickly here. That one we should be pretty familiar with. Your sine graph, remember, starts at 0, 0. And just follow your points. And just move them around. And then what we're going to do is put in your asymptotes. We're going to have asymptotes at 0, pi, and 2 pi. And then the only difference between tan and cotan is they are still going to have a point on the axis right in between the asymptotes, but cotangent goes down as we go left to right. So a cotangent, a positive cotangent, always goes down. See if you can come over here and fill in your domain. X such that x does not equal your first, you can list any asymptotes. You can list 0 or pi. It doesn't matter. I'll list 0 plus or minus the period, which the period is just pi k. And the range, just like before, is negative infinity to infinity. Okay, so the only difference for cotan is that you're first graphing sine and that it goes down as you go left to right. All right, let's try number 5. So number 5, it says 2 cotan x plus 1. So I'm thinking to myself, I am first going to graph y equals 2 sine of x. Deal with the vertical shift last. Okay, period for sine, 2 pi over b. So just 2 pi. So set it up. Okay, if I'm going to graph sine, they always start at 0, 0. Up to 2 because it was a positive sign. 0, negative 2, 0. Draw it in real nice and light. And then I think PAV. P stands for phase shift. There's no phase shift. So I'm ready to go with my asymptotes. My asymptotes are going to be at 0, at pi, and at 2 pi. Done with asymptotes. And then if there's a vertical shift, we want to do the vertical shift now. So think about this for a moment. Normally, we would have a point here. Tan and cotan, we always have a point on the axis. But this says move it up 1. So I'm going to take this and I'm going to move it up 1. I'm going to take this and move it up 1. So my new points are going to be up 1 here and up 1 here instead of being on the axis. Then we have to think we are graphing a cotan graph, which means as I move left to right, I go down. So it's going to look like this. Okay, try to fill this out. Check your domain and range with mine. You do not need a 0 here. If your asymptote's at 0, you don't need to repeat that right there. Okay. And let's try our last one, number 6. Okay, so problem number 6. It says cotan. So I'm thinking first cotan is cosine over sine. So y equals sine of 2x is going to be first. The period for this sine graph is 2 pi over b, or just pi. Set up that x-axis. We're going to go out to 2 pi, but since that's not the period, we are going to break it into b sections. So we're going to break it up into 2 sections. And then we're going to take this period and break them each into fourths. Pi over 2, pi over 4, 3 pi over 4. Half, half again. Amp is just 1 for the sine graph. Cotan and tan do not have an amplitude, but sine is up at 1. All right, sketch that sine graph in. Start at 0, 0, and plot your points. Okay, if we have a phase shift, it's time to do it, but we don't have a phase shift, so we're done with the P in PAV. Now it's time for asymptotes. So let's put our asymptotes in there. There, wherever that sine graph is 0. And it looks like I have 5 vertical asymptotes for this one. So I'm done with my asymptotes. And now think about, normally a cotan has a point on the axis, but I'm supposed to shift it down 1. So I'm going to take all those points in between the asymptotes and I'm going to shift them all down 1. Normally, they're on that x-axis, but they're all shifted down 1 now. Then we think this is a cotan. Cotan graphs always go down as we move left to right. So draw in your squiggle. And it's going to look like this. Try to fill out the information on the left. Okay, once you've got it all checked, I have a question for you. Do you think that negative tan x would be the same exact graph as cotan x? Do you think that negative tan x is the same as positive cotan? Remember, negative tan goes down as we go left to right. And a cotan always goes down as we go left to right. So would the graphs be exactly the same? And the answer to that is no. They'd have the same shape, but they would have different asymptotes. The reason they'd have different asymptotes is tangent is made up from sine over cosine. That's where we get the asymptotes. And cotangent is cosine over sine, and that's where we get the asymptotes. Okay, great job, guys. I know it's not exciting to watch a video. Tonight's homework is to do number 3 in your packet. So please try it now. And what you don't finish, finish for homework. And our next mini quiz is not next class. I know the unit plan says it's next class. The next mini quiz is not going to be until Wednesday. So I will clear up any questions that we have in class on Monday, and I hope that you guys have a great weekend. Email me with any questions you have.